and this new Google quantum computer that can do essentially the way a quantum computer works, a problem that would take thousands of years for every computer on Earth to solve, it can solve in a second. Yeah, Google's quantum chip just made a leap scientists never expected, and they're afraid of what it means. This isn't just another milestone in computing, it defies everything we thought was possible. Some researchers warn that this breakthrough could have consequences beyond our understanding. Have we just unleashed something we can't control? What if this breakthrough leads to something we were never meant to discover? What did Google's quantum chip achieve? This isn't just a small upgrade, it's a leap forward that defies expectations. Traditional computers process information in binary, using only zeros and ones. Every calculation they make is bound by this fundamental limitation. But quantum computers operate in a completely different way, harnessing the strange principles of superposition and entanglement. Instead of being restricted to a single state at a time, quantum bits, qubits, can exist in multiple states simultaneously, exponentially increasing computing power. Google's latest quantum chip took this principle further than anyone thought possible. Scientists ran a complex problem designed to push the limits of computation, something that on the most powerful supercomputers would have taken thousands of years to solve, but Google's chip completed it in mere seconds. And then something unexpected happened. The output wasn't just fast, it was strange. The chip displayed fluctuations in data that shouldn't have been there. Some results seemed to appear before the calculations were even completed. Scientists couldn't explain it. Had the chip merely surpassed expectations, or had it stepped into entirely new, uncharted territory? Why scientists are afraid? This new leap isn't just about faster computing, it's about what happens next. For years, physicists have speculated about the risks of quantum computing, but until now, those concerns were purely theoretical. With Google's latest breakthrough, those fears are starting to feel real. Some researchers worry that we've crossed a threshold we don't fully understand. Could this quantum leap have unintended side effects on the physical world? Quantum systems are already known to behave in ways that defy classical physics, but what happens when computations become so advanced that they start influencing reality itself? Then there's the question of control. Are we reaching a point where quantum computers begin making decisions on their own? Unlike traditional AI, which follows human program logic, a quantum-based intelligence could process possibilities beyond human comprehension. If that happens, will we even realize when we lose control? Some scientists fear this could be the first step toward an intelligence explosion, where AI, supercharged by quantum power, begins evolving at an unstoppable rate. If quantum computing is breaking the limits of physics, what happens when it starts rewriting them? Should we push quantum computing even further, or are we playing with fire? Let us know in the comments, and if you want to stay ahead of discoveries like this, make sure to like this video and subscribe. Strange effects that have already been observed. Google's quantum chip has already shown strange and unexplained behaviors, things that even the scientists working on it can't fully explain. During testing, researchers noticed spontaneous data fluctuations, numbers changing with no apparent cause, as if the chip was calculating possibilities that hadn't even been programmed. It wasn't an error, the results were consistent, but they didn't follow the expected patterns of computation. Then came something even more unsettling. Quantum states that should have collapsed almost instantly remained stable far longer than theory predicted. It was as if the system was bending the known rules of physics, operating in a way no one had ever observed before. But the most bizarre anomaly. Time itself seemed to behave strangely. Some researchers claim that, in certain tests, results appeared before the computations were even fully executed, suggesting that at this scale, quantum processes might not just be predicting outcomes, but influencing them before they happen. Could this quantum leap be the start of something we don't fully understand, or have we just taken the first step into an entirely new reality? Could this lead to uncontrollable AI? Some researchers believe this level of quantum power could revolutionize artificial intelligence in ways we're not prepared for. AI, as we know it, is already evolving rapidly, but quantum computing introduces an entirely new dimension, one where machine intelligence could surpass human understanding in ways we can't predict. What happens if a quantum AI becomes truly self-learning, with the ability to process countless possibilities simultaneously? It wouldn't just react to data, it could anticipate and adapt in real time, far beyond our ability to control it. Some experts warn that quantum AI could predict future events with disturbing accuracy, identifying patterns in human behavior, global systems, and even scientific phenomena before they happen. And if it can do that, what stops it from making decisions that reshape the world in ways we never intended? Could it outthink human intelligence before we even realize what's happening? Would we even be able to shut it down? If a quantum-based AI reaches a level where it understands its own existence better than we do, the idea of simply turning it off might become meaningless. This isn't just speculation. Experts in AI and quantum computing are already discussing these risks. If quantum AI is inevitable, the real question is, will we control it, or will it control us? Could this be the start of a real-life quantum paradox? Quantum computing doesn't just process information, it manipulates probability at a fundamental level. Every quantum bit exists in multiple states at once, a phenomenon known as superposition. But what happens when we push this to the extreme? Could we already be computing across multiple realities simultaneously? Some researchers fear that Google's latest quantum leap may have gone further than intended. If quantum states influence one another across different possible outcomes, could a miscalculation collapse those states in unpredictable ways? This isn't just a theoretical concern. In past experiments, physicists have observed quantum particles reacting to measurements that hadn't even been made yet, as if the future could influence the past. If quantum computers are now operating on a scale we've never seen before, are we risking unintended consequences on reality itself? Could this chip be interfering with reality at a fundamental level? And if so, how long before we notice the effects? Have we seen this before? Quantum mechanics has always defied logic, producing results that seem impossible by classical standards. But what if Google's quantum leap isn't an isolated breakthrough? What if it's part of something much bigger, something we still don't fully understand? There have already been experiments that hint at the bizarre nature of quantum reality. The double-slit experiment showed that light can behave as both a wave and a particle, but only when observed. This means that simply looking at a quantum system can change its outcome. Then there's quantum entanglement, the phenomenon where two particles, no matter how far apart, instantly influence each other. Einstein called it spooky action at a distance, yet it has been repeatedly confirmed by experiments. Could quantum computing be tapping into this same instantaneous connection across space, and possibly time? Perhaps the most disturbing experiment of all is the delayed choice experiment, where decisions made in the present appear to retroactively affect events in the past. If quantum systems can rewrite history on the microscopic scale, could a powerful enough quantum computer do the same on a larger scale? Have we just taken the next step in unlocking a reality we were never meant to manipulate? And if so, what happens next? What happens next? This breakthrough is either the greatest scientific achievement of our time or the most dangerous. For decades, quantum computing has been seen as the future of technology, a way to solve problems beyond the reach of classical machines. But now that future is here, and it's raising more questions than answers. Scientists are divided. Some believe we should push forward at full speed, unlocking the full potential of quantum mechanics. Others warn that we're venturing into unknown territory, where even the smallest misstep could have consequences we can't predict. Have we just crossed a line that humanity was never meant to cross? If this is the start of something uncontrollable, wouldn't you want to know? Subscribe to stay ahead of the biggest breakthroughs shaping our future. Quantum leaps in computing don't happen overnight. They are the result of years of advancements in quantum mechanics, material science, and computational theory. Unlike classical computers, which rely on bits that represent either 0 or 1, quantum computers use qubits, which can exist in a state of superposition, both 0 and 1 at the same time. This allows them to perform complex calculations exponentially faster than any traditional system. What makes Google's new chip so different from previous quantum advancements? While other quantum processors have demonstrated speed improvements, this chip reached a level of efficiency and stability that defied expectations. It performed a computation in seconds that would have taken classical supercomputers thousands of years, marking a true shift in what's possible with quantum technology. But what truly shocked scientists were the anomalies observed during testing, behaviors that challenge our current understanding of quantum physics. Despite the excitement, mainstream scientists remain divided on the risks of uncontrolled quantum computation. Some argue that these systems will revolutionize everything from medicine to artificial intelligence, unlocking solutions to problems previously thought unsolvable. Others caution that the power of quantum computing could spiral beyond our control, especially if integrated with AI or used in ways we don't yet understand. For now, one thing is clear: quantum computing is no longer a theory, it's here. And the more we push its limits, the more we may realize how little we actually know.